Did it beep? No, it did not beep. Why not? It did. I just didn't hear it. All right. First graph that you were asked to construct. Double check you have the correct title on that graph. The title should be volume versus pressure. Volume versus pressure. If you did pressure versus volume, that would be marked wrong. If you left a title off of it, it would be marked wrong. All right, so it needs to be what's on the y-axis versus what's on the x-axis. Volume versus pressure, no units, just the variable names. On the y-axis, you should have put the label volume in milliliters. On the x-axis, you should have put the label pressure in torr. Now, in terms of scaling, I can't tell you what scale you should use. It all depends on what type of graph paper you have and how many boxes you have going over. But try to pick something easy that is easy to count by in your head as decimals, okay? So I did, based on my graph paper, I chose on my x-axis to do every line was 100. That gets me to the maximum pressure that I was given 1,000 and beyond. You want to always make sure you can go beyond, because sometimes we have to extend our lines to figure out what would happen if we increased a value beyond what's there. Same thing on the y-axis, rather. I did every other line was 100 because I had enough room, and that gets me to the maximum value I was given on the volume scale of 800 and beyond. Now, double check this with me. You need to have 1, 2, 3, 4, 5, 6, 7 data points, yes? Either marked with little X's, little pluses, or dots with little circles around them. And then you need to freehand a nice smooth curve as best you can. Don't try using a ruler to do this. This is not straight at all. You freehand as best you can with a pencil. We don't want to see bumps in it. Try to make it as smooth as you can. Does it have to hit every point? No, but it should be pretty close.
So the best fit goes past the data points?
Yeah, we extend it in both directions. So you can see I go up here, and I've gone beyond over here too. Okay. And that's because, remember, the purpose of a graph in science is to look for patterns. And sometimes what we have to do is kind of envision, if I were to continue this pattern in this direction, what would happen? What would the value be? If I continue it in this direction, what would be the value? If you don't extend your lines or curves, in this case, you can't do that. Okay. You're familiar with those types of questions in math. They show you numbers and they say, okay, or on the SATs, on the math section, they're going to give you a series of numbers and ask you what's the next number in the series, something like looking for patterns. That's exactly the same idea. Patterns. Yep. No, we do not put arrows on these. I think in math you might, but here we don't. Okay. Any other questions on graph 1? Okay, let's look at your second graph. The second graph needs to be titled distance versus time. Not time versus distance. If you have it backwards, fix it. If you left off a title, add it. You got to have the dependent variable versus the independent variable. That means distance in meters should be on the vertical scale, and time in seconds should be on the horizontal axis. Now, what I did to scale mine on the x-axis, I did every other line was a second, so that gets me to the 5-second mark and beyond. And on the vertical axis, I did every line was 10, but I just labeled every other one. And that gets me to the maximum distance and beyond. Okay, now let me expand this. So you can hopefully see the whole graph. That's pretty much the whole thing except the title, which is off the screen right now. And so let's double check. You should have 1, 2, 3, 4, 5, 6 data points. And then we should have a nice smooth curve as best you can to draw that. Again, no bumps in it. Try to make it as nice and smooth as you can. Notice that this data point wasn't on my curve. And am I going to be upset about that? No, because this is a best fit curve. What that usually means is that that data point, which was collected in an experiment, has some error in it. right? Anytime you do an experiment, the data that numbers you get are not what the real number is from nature. There's some error in there. We got to figure out where it is. The real number should have been right on the line, but the experiment gave us that number, which was slightly off the line. We're trying to figure out where was it for real? Where should it have been if there was no error? And that's what this curve will show you. Okay? Questions about that one? All right, then let's look at our third and final graph, which should have been titled speed versus time. Not time versus speed, speed versus time. Speed in meters per second should have been labeled on the Y. Time in seconds should have been labeled on the X. Again, I was able to do every other line was a second on my X-axis. I don't know about yours, but remember, we're trying to use up at least 2/3 of a page. On the vertical scale, I did every other line was 20, or every line was 10 meters per second. And that gets me to my maximum time of 5 seconds and my maximum speed, which is just over 100. Now, double check your data points. 1, 2, 3, 4, 5, 6 of them. You should have been able to tell if you tried to kind of connect them with your finger. This is what I do to try to figure out, is this a line or curve? I take my finger and I try to connect them because my finger is a little fatter than any line I would draw. I just put it over and I go, oh yeah, that's kind of in a linear trend. So therefore I need my ruler now to draw something best fit. And you can see on this one, you should not have had all of those points on your line. Some of them should be off, but you're doing this with a ruler. Can you see that that was done with a ruler? It's really straight. That's what I'm looking for from you guys. No little bumps in it. Otherwise it was freehanded. Okay, any questions? All right. So for today's quiz, you can use your graphs. You know, if you want to look something up to kind of give you, oh, what goes first, where, do I have everything I need? You can have out your graphs. You do need a pencil and ruler. I'm giving you graph paper for this to help you construct. You're going to make one more for me so that way I can verify that you understand how to make graphs by hand. Please put your name on top of the quiz when you receive it. Your class period is 8. You're welcome. When you finish today's quiz, I want you to raise your hand so I can collect it. Okay? You're welcome. Trying to make sure that I can't tell you how many times. Yeah. Your mom had to pick both 8 names for you. Yeah. Yeah. once I have your quiz, you'll need the 5 items that are up on the chalkboard. Did I get everybody's quiz? Okay. Before we continue, I am not going in the order of the agenda up here. I'm going to switch what we're doing. So we are actually going to talk about interpreting the graphs that you now have made, and what you need to be able to do with these graphs in terms of kind of getting information from the graphs. What kind of patterns are there? Those kinds of things. And then what we're going to do once we finish that is we're going to learn how to start doing all of this in Google Sheets. Doing this in Google Sheets is not something you would be tested on a Regents exam or even on a unit exam, because none of our tests are digital in format. Thank God. Okay. I can't imagine if we gave our test on a computer how that would go. Having to type equations and do no. So this is, I'm teaching you this, how to do it with the technology we have, because we're going to use the technology in labs that we do, but also because once you leave high school, you go to college or you have a job, you're going to be doing all kinds of graph stuff electronically. You're never going to make one by hand after you leave high school. I shouldn't say never. With like 99.99999% certainty, I don't think you're ever going to make one by hand again. All right. For our course, our exam at the end of the year, you got to do it by hand. For a unit test, you got to do it by hand. But then once you go off to the real world, whether it's academia or a job, you're going to be doing it all electronically. So I want to teach you how to use the technology that we have available to us, so that way you can do it. I have known students who got really good at making graphs in Google Sheets. They put it on their resume, applying for a summer job or internship, and they were able to get jobs that started at $20 an hour, where all they were doing was making graphs for publications and things like that. Professionally, because you will know how to do it like a professional when we're done. So put this skill on your resume later, that you know how to use Google Sheets to do graphing, which is really a very, very good skill to have. Okay, so enough of that. Let me shift over to my notes then. And whatever there are two problems that I plan to give you for homework tonight. Did I present the right thing? No, I did not. There we go. And they are in your packet on pages 17 through 19. So when we get there, I'll just highlight which ones I want you to do. So what we're going to do, and this will finish unit 1, by the way. This is the last set of notes for this entire unit, which means that next week you'll be taking a test on everything we've been doing since the first day of school, all of unit 1. Your test will be a week from today. At least that's where I have it on my calendar right now. Things always can change, but right now that's my plan, is to test you on this topic on Wednesday next week, which means tomorrow I will be giving you a review assignment to be working on for about 4 days. We'll go over that review assignment the day before your test, and then the next day you take a test. So it's really important you do the review assignments. I never come around and check if you do the review, like I do this homework. It's pretty obvious to me if you've done the review when you take your test. Because if you don't do the review, generally, what do you think your test grades are? Not good. Yeah. So the review is really meant for you to practice. And I would think you would want to practice before you take a test to kind of make sure you know what you're doing. You feel good going in. You're not so anxious. So just keep that in mind. Anyway, what we're now going to do, as I mentioned, is learn how to interpret the graphs that we've made. And these are the kinds of things that I'm going to ask you to do with the graphs that we have all year. The first thing that I could ask you to do is like flashcard kind of stuff. If I give you a graph, you have to be able to tell me the exact shape of that graph. Then once you've determined what the shape is, same idea, you can quiz yourself with a flashcard, is name the relationship between the variables that are on that graph. And then if the graph happens to be a linear type of graph, we ask you to do some math with these line graphs. Like figure out what's the y-intercept value, calculate the slope, and then write the equation specific to the graph that's in front of you. And I'll show you how to do that because a lot of this is different than what you've been taught in your math classes. Or it's more specific because, again, the graphs you deal with in math are just for general equations. No actual data or measurements from an experiment. Everything we have here comes from an experiment. So could you start off by just drawing sketches of these graphs in your notes? You don't need a ruler or anything like that. You don't have to label the axes either. Just show an X and a Y axis and then put the lines or curves that are there. And what we're going to do is label each of those with the shape. This is so we can identify what shape is each of these. What shape is each of these graphs? I think I'm going to turn off a set of lights so it's a little easier to see. But you got to promise me you're not falling asleep. Okay? No falling asleep even though I turned off the lights. So the labels on the axes right now don't mean anything. We're just talking about what is the shape of this? What is that shape? What's this? What's this? What's a graph that looks like that? What are those shapes? So if you were to make a flashcard, I would think you might put the shape of the graph on the front, draw that picture, for example, and then on the back, you write down the shape. Shape is blank. Just keep quizzing yourself, right, to help you remember. Okay, ready? The first one? The first one here, there's going to be 4 different shapes, even though we have 5 graphs. The first one right here, go ahead and label this one. This graph specifically is the horizontal line. So if you just said horizontal, I'm not going to give you credit because you're not telling me it's a line. It's a line, but it's a special type of line. It is a horizontal one, like the horizon. It goes sideways. Horizontal line. The next one right here is a line as well, right? But it's different than that one. What kind of line is this one? Diagonal. That is called a diagonal line. So go ahead and label this graph a diagonal line. Okay, these two are the same shape. but they look different based on the equation that we write for them. Both of these are curves, but we don't say the shape is a curve. It's not specific to these types of curves. Those two curves are called parabolas. You heard of a parabola before? Probably from math class. Those two are parabolas. These two right here. So label both of those parabolas. Now let me just kind of explain to you what's different about them. This parabola, a parabola actually, if I were to continue it, would go up and then it would come back down. You're familiar with that? Same thing here. If I were to draw the rest of the parabola, it would go on the other side. They make U's, like a U. It kind of opens up in one direction. This one is said to be a concave down parabola. This one is said to be concave up, meaning if I were to draw the whole thing, the U would point up, the opening would be up. The other one, if I were to continue it, here, it would now point down. So we would say that's concave down. But they're both parabolas. The last curve over here is what we call a hyperbola. Hyperbola. Now, I'm not a super fan of that particular hyperbola. Let me show you what's different about a parabola versus a hyperbola. This is a hyperbola. That's a better drawn hyperbola than the one here. Let me explain how you can tell if the curve you have is a parabola or a hyperbola. There's one feature you're looking for. If it is a parabola, the graph, if you continue it back to an axis, will actually go through the axis. It will intercept it, either the x-axis or the y-axis. A hyperbola, if I were to continue this curve up and continue this curve down, would never, ever, ever touch either axis. It's asymptotic towards the axes. You heard of an asymptote before, Matt? Okay, these are asymptotic towards the axes, where parabolas will intercept an axis. That's how you can tell the difference, okay? You're looking for that feature. All right, now let's talk about the relationships. So that's it for shapes. The relationships. The first relationship we have occurs when you have a diagonal line that has a positive slope, meaning it's slanted upward. This is what we call a direct relationship. Direct relationship. Now, the general equation for this diagonal line with the positive slope takes the form of y equals mx plus b, but notice that I'm telling you the slope of this must be positive. That positive on the slope of this line is what gives me what we call a direct relationship. It's a direct relationship. Okay, can I go on to the next one? Okay, the other diagonal line we might see is the one with the negative slope. I said we might see it. In this class, you're never going to see it. You're never going to have a graph with this relationship in physics, but I'm teaching it to you to be kind of comprehensive on things. If I were to have a negatively sloped diagonal line, we would say that those variables have an indirect relationship. It's still y equals mx plus b, but what makes it indirect is the fact that this slope is now negative. Now there's one more line graph, and that's the horizontal line graph. That's going to give us our third relationship. If you had a horizontal line graph, we would say that the relationship between those variables is a constant one. Now, if it's a horizontal line, I think you know the slope of that line is 0, which means the mx term of y equals mx plus b is going to drop out because m is 0. So it just leaves us with the equation of y equals b. What this tells us is that, as in this case, the time goes on, the position was constant. That's why we call it a constant relationship. Okay, now let's talk about both parabolas. Both parabolas, whether they're concave up or concave down, are said to have a quadratic relationship between the variables. Have you heard of the quadratic equation before? Okay, quadratic things have a squared term on one of the variables. So I remember when I took math here at Colony many moons ago, it was like y equals ax squared plus bx plus c. It was like the general equation for a parabola. Okay, the fact that there was a square on a term is what we made it what we call quadratic in nature. Here, all our parabolas are going to basically originate at the origin, so the bx plus c part always drops out. So we just say that the general equation is either y equals kx squared is what you get for this type of parabola that's concave up, or if it's concave down, it usually takes the form of y squared is kx. So it's not always the x that has to be squared. The y term could also be squared. If either term is squared, it's said to be a quadratic equation, a quadratic relationship between the variables. You ready for the last one? That goes with the hyperbola. If you have a hyperbola, you have what's called an inverse relationship between the variables. Pretty much any graph where one thing is going up and the other one is coming down is said to be an inverse relationship. And the general form of the equation for every hyperbola is y equals k over x. Y is k over x. All right, so this is the stuff you just kind of have to memorize. Well, it's just stuff you have to memorize or look it up when you need it. Last thing we have to do is now talk about these line graphs, because if they're line graphs, we now expect you to do some calculations with them. Let's go over what you have to do with a line graph. The first thing you have to be able to determine is what's called the y-intercept for that line graph. In mathematics, we use a lowercase b to represent the y-intercept. And when you look at looking for a y-intercept, you're just reading the graph. You just read your graph. There's no calculation for it. Basically, read your graph at the x-coordinate of 0. Ask yourself, what is the y-coordinate when the x value is 0? That's your y-intercept. So if I gave you a line graph that looked like this, I say, okay, this is where my x value is 0. I go up and I read off that value right there. One mistake that kids often make when we're asking you for a y-intercept is they give me the y-intercept in x, y coordinate notation, like 0, comma, something. That's not a y-intercept. The y-intercept is just the y coordinate. You already know the x has to be 0, so don't give it to me. Okay. The other thing you have to be able to do, let's say that I had distances on this axis in meters. You read off that number, but then you have to recognize that the label on the axis is kind of like your column heading, where every number there has the same units as what's on the label. So if this was distance in meters and that value was 5, you're not going to tell me that the y-intercept is 5. You're going to tell me it's 5 meters. You understand the difference? You have to give me the units which come from the label on the graph. Think of it like a data table. The label is their heading. You get the units from the label, from the heading. Okay, the next thing you have to be able to do is find a slope, calculate a slope. In math, you use a lowercase m for it. In physics, we're never going to do that. We're going to use the word slope. We're going to write out S-L-O-P-E. And there's a reason for that. We use lowercase m for mass in physics. So if you write little m equals something, we're going to think that means a mass is something. So we're actually going to write out slope. All right. The way we calculate a slope is by doing a change in y over change in x, or a rise over a run. This is actually the version of the equation we will use in our class. y2 minus y1 over x2 minus x1. Does that equation ring a bell? I think you use it in, oh geez, when do you learn the slope formula? Is it Algebra 1 when you do that? Okay, so that was a while ago. So what we're going to do, folks, on your reference table, I did ask you to have out your reference table, right? Okay, if you look in your reference table, here's page 6 with all the mechanics stuff. Page 7 is opposite that. It's all blank. I like that because that gives us a place to write equations that we need to kind of memorize when we go to take a test. So what we're going to do is write a couple equations that we need to know for Unit 1 here on page 7. So let's go ahead and make a list for Unit 1. What do we need to know? As I just mentioned to you, you have to know the slope equation. And the version I want you to use is y2 minus y1 over x2 minus x1. Yes, sometimes we will ask you just to calculate the slope of a line and show your work. Okay. You'll be asked to just calculate the slope starting with that equation, and that is not on your reference table anywhere. So you got to know it. The other equation that we learned in Unit 1 that you're going to have to know for your test next week is your percent error equation, which is the absolute value of the accepted value minus the measured value all over the accepted value times 100%. Ring a bell? So you'll need to know that for your test next week as well. Putting them now on our reference table gives us a place to just kind of quickly go back and look for it instead of having to go through our notes every single time we need it in class. Bless you. Okay, is everybody set with those? Okay, so let me go back to this. When you're finding your slope, this is a difference from math. Remember that in a math class, you're just dealing with general equations that somebody made up, a theoretical equation, you're plotting it, and there you go. None of it comes from actual data from an experiment. In our class, every graph you're making comes from an experiment where there are some errors. So the question will say, calculate the slope of your best fit line. It will never say, calculate the slope of the data in your table. I want you to find the slope of a line, which means that when you're doing your slope calculation, you have to use points that are actually on the line you drew. If you pick a point and you plug it into your equation, and that point wasn't on the line you drew, you lose credit. Because that wasn't a slope of a line that you just found. You just found the slope of data in a table. Can I give you an example of that? What I mean? This was the third graph from last night's homework. Our graph of speed versus time. Look at that point right there. Is that point on my line? Okay. If I plugged in that point, which I could get from the data table, into my slope calculation, that would be wrong. Because is that on the line? No. How about that one? If I put that into my slope formula, is that going to be right? No, because it's not on the line. That one also isn't long. Okay. You don't always have to use data points, though. Let me show you what I mean. You see this point here? There is a point on the line right there, even though I didn't put a dot. I'm putting the dot there now so you can see it. I can easily read down to get the x coordinate, and I can easily read over to get the y coordinate. I can use that in my slope calculation. That's not a problem. All right. It doesn't have to be a data point, but it's got to be on the line in order for it to work. Here's a couple other differences with math. Your math teachers, I think, allow you to write your slopes as fractions. Does that ring a bell? Okay. You can't do that here. Let me explain why. Every number we work with all year is a what? Starts with an M. It's a measurement. And every measurement has significant digits. So what do I need you to do with your slope? Divide it out on the calculator and give me an answer with significant figures. That means you got to put it into a decimal type of form. So make a note of that somewhere. You're not going to use fractions. You have to divide it out and give me an answer with proper significant figures. And units, that's the other thing. All our slopes are going to have units that come from the units on the graph. So please make sure your slopes have significant figures and units that come from the measurements on the graph. I feel like I'm being like super picky, but unfortunately, I think the math teachers are they're just making stuff up. We don't make stuff up in science, Okay, we're getting stuff from the universe, from nature, and so that's what we got to work with. Kind of in the real world, that's how it is. Unless you become a theoretical or analytical mathematician, you're going to have all this stuff you got to worry about. Okay. Any questions on that? Okay, the last thing you have to know is how to write the equation for a graph. I think we all know the general equation of a line is y equals mx plus b. But that isn't specific to this graph that you made for homework. We're going to learn how to write the equation for that graph. So everybody's graph would look exactly the same from the equation. So here's what we have to do. Your final equation will not have a y, it will not have m, it will not have x, and it will not have the letter b in it. Every letter in there gets changed. The letter y gets changed to the actual variable that you put on the y-axis. So the example for homework, this one here was the speed versus time graph. You're going to change the letter y to speed. So I know that speed was on the y-axis. You're telling a person who looks at that equation, oh, speed was my dependent variable in this experiment. You're going to do the same thing with the letter x. Change it out. What was on the x-axis of your graph? This graph had time on the x-axis, so we're going to write time instead of x. For now, because we don't know what the symbols are for these variables, we're actually going to write out the word, speed and time. You're going to change out the letter m to the slope value that you calculated along with the units and significant figures. And you are going to change out the b to the actual y-intercept of your graph, including the units. Once you do this once or twice, you'll be like, oh, it's really not that big a deal. But it makes it very specific so that way we all end up with the same exact graph for that experiment. You're telling somebody that they needed to start at the origin. On the y-axis was speed, on the x-axis was time, and it was slanted up. How much did it go up? It went up 20 meters every second. Otherwise, it's off by a different amount. Okay, so you're telling them exactly how steep to make the line, where to start the line, and what the variables were in the experiment by doing that. All right, that's the last set of notes. That's it. No more notes for Unit 1. Okay. Can we turn in our packet to page 17, please? And I'm going to do 2 of the 4 graphs that are given to you for practice with you. And then the other 2 I'm going to ask you to do for homework. I think that's fair. So, and you'll see it's not really, doesn't take that long. And then the rest of our time today will be learning how to do stuff on Google Sheets. And if we finish that early, then you'll have time to work on this. Okay. Let's take our break. Go ahead, take your break. And when you come back, we'll work on this.
Oh, yeah. Dude, we need to use like Indiana sales. I know what it's why is he up? He also does. Yeah. But he also does. Yeah, I can't wait to watch tonight.
I know. Maybe I gotta watch this thing now.
Huh?
Maybe I gotta watch this on reason.
No, he won't.
Yes,
Do you have
I sure do. You want to start now? I'll get behind you over here. You're welcome.
It's like a Madden game. Just go on it and search and see what play you like. Yo, we need to run middle screen one. It works. I don't freaking use it. For which one? This is the one that slow messed up. We're supposed to like motion Jackson. He's supposed to run the wheel, and then that receiver is supposed to run a post. Slow is supposed to go with the wheel. The wheel. It's an actual wheel.
All right. Let's get started, please. Page 17. Page 17. I'll have this out. Okay. Just a quick note. We're supposed to have a fire drill around 1:30. Just to review. When we go out to the left, keep everything here. I'm going to lock up the room. We go out beyond the cars on the side. Leave everything here. You are not scratching up my car when you go out there. Go beyond the cars. Look for me. Line up in a straight line facing me. No electronics, obviously. And your mouths are zipped shut. So we can hear announcements to come back in. Okay? Get a little break. Okay. Numero uno. Part A. Here's your graph. Which variable is independent? Position or time? It is time because it's on the x-axis. Letter B. Which variable, time or position, is dependent? Position because it's on the y-axis. Part C. Name the shape of that. That is a diagonal line. Remember, if you just say diagonal or just line, that's not specific enough. You need both words. Letter D, can you name that relationship? Direct. Very good. Okay. E is where I have to show you what we do in physics. Go back to your graph. I want the slope. You need 2 points on this line. I want you to circle the 2 points. Try to pick ones that are as far apart as possible. Well, it turns out that the first and last points are on the line. So let's go with those. Label them. That is point 1, and this is point 2. Now, before you go on, you're not just going to the calculator. You got to show me all kinds of work. Right? We use our guess method to solve problems. So let me show you how you write your givens for this. The givens are going to be for point 1 and point 2. You're going to give me those coordinates in XY coordinate notation followed by their units. So point 1's X coordinate is 0 seconds. The Y coordinate is 100 meters.
Good afternoon, Colony High. This is Mr. Jetty. Please be advised that in a moment we will be having our second fire drill. Teachers and staff, just a reminder, If you have not done so already, please be sure to review the evacuation procedures
Let's
with
do
your
it.
class.
Come on.
Also,
Get things
If you have
going.
a free period,
I
please
don't.
assist in ensuring students are quiet and evacuate in an orderly fashion during this drill. Also, please assist in evacuating any students with medical needs out of the building.
Do you have any
Students,
medical needs? I need to
when the
help you
alarm
out.
bell sounds,
Good, because I
please
can't
exit
lift you.
quickly and quietly, following the instructions of your teachers at all times. During the drill, it is essential that you remain silent. Phones and other electronic devices are not permitted during any drill and should already be secured in your lockers. In the event of a real emergency, being able to hear clear directions from staff and administration
tell me
or
what the
law
coordinates of
enforcement
point
is
two are?
critical for everyone's safety. We also understand that students have
5
reported difficulty hearing announcements
seconds.
sometimes in the hallways between classes, which is another reason why your full attention during drills is so
1,400
important.
meters.
Thank you for your attention and your cooperation.
Okay. Any questions on the givens? Notice I put units after every number. The unknown is the word slope. The equation we're going to get from our reference table, page 7, slope is y2 minus y1 all over x2 minus x1. Now you're going to do your substitution with the units. That is 1,400 meters minus 100 meters over 5 seconds minus 0 seconds. Hold on. We don't go to the calculator yet. What is 1,400 minus 100? It is positive 1,300 meters. I can guarantee you the building is not burning. Hold on. 5 seconds minus 0 seconds is 5 seconds. All right. We will get the final answer to this after this drill. Let's head on out. But we don't have to run because the building is not burning. And we are quiet, not talking. Oops, sorry.
Oh, I'm sorry.
That's all right. I never look where I'm going. I just go. Figure everybody else has to watch out for me. All right, where'd everybody go? Come on, come back in. Where'd the rest of our class go? Are we excited to finish this?
Yes.
Yes,
I am.
Come on, let's get back in.
Are you excited? I am.
Are we back?
Looks
Yes. Oh, wait. Almost. Where's Angela? And Braden.
I'm really proud. I feel like you should
Braden, come
I
on.
feel like it's kind of judging me.
The rest of your class is here.
I feel like that's a little necessary.
Lost.
Well, to be fair,
Not lost. All right.
A lot of people.
Okay, here's what we do now. You have to divide that out. Divide it out on your calculator. Even though it looks like a fraction, you have to divide it, get an answer as a decimal. So go ahead and divide it out. This is, or floating point notation rather. Now that's not the answer to the problem, because you have to ask yourself, how many significant digits should you get? Look at the numbers that we divided. How many significant figures are in the numerator? How many in the denominator? So how many do you need on your answer? 1. Can you round that to one significant figure? What is it? Okay, now let me show you how you write your final answer to this. The numerical value is 300. You do have to tell me whether the slope is positive or negative. So I know which way the line slanted. Which way did it go? Up? Is it positive or negative? It's positive. So please make sure you put the positive sign out
Students,
front.
you should be on your way, if not already, in period 9 class.
Okay,
Again,
thank you.
students, period 9 class. Here we go.
You will learn next week what that positive sign means. It has a meaning in physics. The units of this come right from here. What do you think the units are? M over S, a meter per second. Okay. Letter F now wants the equation for this graph. You're going to start with the general equation for every line graph, which is, thank you. You write that so that way you're sure you're changing everything out that needs to be changed. So my first question for you is, look at the graph that you were given. What was on the y-axis of this graph? What variable? Name it. Position. So you're going to write the word position. Once we learn some physics, we'll know what abbreviation, what letter we use to abbreviate a position, and we'll change it to that. But right now we write position. Do we know what the slope of this graph is? We just found it. So you're going to include that here. Positive 300 m over s. What was on the x-axis of this graph? So write the word time. Eventually you'll know what letter we use to abbreviate time with as a variable. And then you're going to change out the letter B to the y-intercept on this graph. So let's look at the graph. Remember, the y-intercept is the y-coordinate when the x value is 0. So here's my 0. I come up. What number would be here? 100 meters. So we add plus 100 meters. Now this tells me that the graph we had in front of us was a graph of position versus time. Just looking at the equation, it was a position time graph that started at 100 meters on the y-axis and went up 300 meters every second that I went over. It's very specific. Otherwise, it's just specific. It tells me it was that graph and that graph only. That's why you're going to do that. Okay, number 2 is homework. So that means all of page 18 you're going to do for homework. Let's go to page 19. I'm going to do 3 with you. I want you to do 4 for homework. Number 3. Looking at that graph, which variable is the independent one? Time. Very good, because it is on the x-axis. Which one is dependent? Distance, because it's on the y-axis. Okay, what is the shape of this? That is a parabola. And what is that relationship? Look in your notes. You have your notes in front of you, right? What's the relationship when you have a parabola? Quadratic. Very good. Quadratic. Quadratic. Okay? Let's put this away. Now you just need your Chromebook. And that will... Now we're going to learn how to do all this stuff with Google Sheets. Look, you're going to learn how easy it is to make a graph in Google Sheets. This is part of the reason we use technology all the time. I want to wait for everybody to get their Chromebook out, on, and opened up to our Google Classroom. Come on. There we are. Yes.
It says that you don't have any Wi-Fi.
You sure do. It's right above you, in fact. So say join Wi-Fi. Oh. Might have to reboot. I don't know. Shut this down. Shut it down. Let's start that. Give it a count to 10 and then start that. There might be isn't there a button on the side of your Chromebook for the Wi-Fi that turns down and off? So you should remember that there was one somewhere in the desk. I don't know. It's like on. I don't know. Nope. Sorry. Okay, we're gonna try to move it up and see what happens. So we're not going to jump ahead on these because I want to. My whole objective. This is classwork, but I want to teach you how to do this so that way, after I've taught you how to do this a couple of times, you can then do any graph I give you, and I don't have to walk you through the steps anymore. But if you are kind of like half paying attention because you're trying to get the paper homework done, chances are when you have to do this on a lab for a grade, you're not going to be able to do it, and you won't get a good grade. So I really want you to kind of just focus, just relax. We'll do it together. It's not hard. Is it booting up now?
No, now it's not turning on.
Is your Chromebook charged?
Yeah.
I don't have a loader.
Oh no, I got it up.
It is gone. Just took a minute. This only takes like 6 or 7 minutes to go through, so we got time.
Oh no.
You got it now?
Yeah.
Excellent. See, when in doubt, shut it down, start it back up. I do that with my phone all the time. There was some kind of update that had to go through. Things aren't working. My personal laptop at home, I got to do that all the time. Just a good rule of thumb. Shut it down when it isn't working. Okay, so we all need to get to our Google Classroom. I'm going to make my screen a little bit smaller so that way you can see things on the screen with me. And what I'd like us all to do once you've gotten into our Google Classroom is go to your classwork tab, and you'll see under Unit 1 that there is a posting for an assignment. It's not an assignment. It's just classwork. The only way for me to push it out so you each have your own copy is as an assignment. Okay. Do you see this assignment graphs in Google Sheets? You see there's a Google Sheet attached. Please go ahead, open it up, click on that link, open it up, and the file will look like this. Great, and let me know when you're there because I don't want to jump ahead of you. You're good? You got the sheet open? Okay. Here's what I want to do first. Before we learn how to make a graph, I just want to go through some of the vocabulary of working in a Google Sheet with you. First thing, this file is called a workbook. Have you ever had a paper workbook before? Lots of pages in it. Same thing with this, except it's basically an electronic file with lots of pages in it. Each page is a different tab at the bottom of the screen. So as we work with Google Sheets for labs, you're going to see I'm going to be pushing out labs to you that have multiple tabs for you to complete. One tab feeds the next, which feeds the next, which feeds the next with data. So it's important for us to understand how these work, and we're not going to manipulate the tabs at the bottom. Just know that you can click between them, and you see as you click between these tabs that you'd get various data tables. Okay. Now come back to the practice problem tab. You'll see that I've given you a table, and I want you all to put your cursor, click the cell that says force with the capital N in parentheses. Okay, is that cell highlighted in blue like mine right now? Okay, come up here, and you'll see that we have what's called the name box. You see when I highlight it, it says name box. Do you see it says A2? Does yours say A2 also? Okay, let me explain to you what the A2 means. Every column, do you see every column is labeled with a letter? And every row is labeled with a number on the left. So when I refer to this cell in the whole sheet, it is cell A2, which means it is column A, row 2. So the value of force is in A2. Can you tell me what value is in cell B8? You'll have it. 7.5. So when I click on that 7.5, do you see how the name box changes to B8? So when I refer to specific locations on the sheet, I'm going to give you the column and row letter number. So that way we're all on the same page with that. You understand where I'm talking about. Okay. Let's now all put our cursor back in cell A2. So that's highlighted. Okay. I would like you all to hold down your shift key. Hold down the shift key. Use now your other hand, right arrow over. So cells A2 and B2 are both highlighted. You do not pick up your finger off the shift key yet. Do you see how your name box now says A2:B2? It's telling you what's being highlighted. Please now use your down arrow key. Keep holding down the shift until your name box says A2:B8. So when we look at this, you can now let go of the shift key. You see that you have these cells right here from A2 to B8 all highlighted. Are you with me? You should not have selected the word table. We never take the title of the table and select it to make a graph. Otherwise, the graph doesn't come out. Okay, don't select that. All right, now go up to your insert menu. A graph in a Google Sheet is called a chart. So come down and select chart. Sometimes Google Sheets knows what type of graph we want. Sometimes it doesn't. This time it does. This is what's called a scatter graph. Now what we're going to do, we have a problem right now with this graph. It is covering up part of your data table. Do you see that on the page? So I'd like you to select your graph, click and drag it over. So it is not covering up your data table at all. I'm going to make my screen a little bit smaller so that way it all fits on the screen. Okay, you with me? Okay, we now have to edit this graph. It did a lot of good things for us, but there are mistakes and we need to fix it. So the first mistake we have is with the title of the graph. Our graph titles never have units in them. So let me show you where we can edit this. There's a bunch of menus in this chart editor window on the right. Please go to the Customize area of your chart editor. And I want you to come down and expand the submenu that says Chart and Axis Titles. In future labs, we're going to have to edit a bunch of these titles. This time, we're only going to edit the chart title. But if you click here, this down arrow, you'll see that it allows you to change a bunch of different things. We're just going to look at the chart title right now. Here is the title where we are going to delete the units and the parentheses. Go ahead and get rid of the parentheses CM and the parentheses capital N. Once you've done that, your title will change to just elongation versus force. Are we okay? Did I lose anybody? Great. Okay. Next thing you're going to always visually look for. On your graph, you want to make sure you always have 0 on the Y and 0 on the X showing to you. This graph has it. Not every graph we do today will. If it doesn't, I'll show you on the next one how to get the 0 and the 0 both there, but you need it. So just keep that in mind. The next thing we're going to do is we inspect the axes labels. The vertical axis title is elongation in cm. That's good. The horizontal axis title is force in capital N. That is good. We don't adjust any of the scaling. We keep it as it is. We do not adjust the grid lines. We don't adjust the colors, none of that stuff. It doesn't allow it to be printed nicely. We want everything so it can easily be printed if necessary. Now we have to add our best fit line or curve. This is done under the series submenu. So please expand the series submenu. And I'd like you to scroll down with me until you see these 3 possible check boxes. Do you see them? Please only select trend line. The trend line means best fit line or curve in Google Sheets. It's called a trend line. Now notice that it gives you options for types. The only 2 that we ever work with in this class are linear and power series. That's it. Which 2 did I just say? Linear and power series. Okay. This one, if you think it's going to look like a line, you should be selecting linear. If it's a curve, guess what you're going to select? Power series. That's it. Okay. Those are your options. That graph is now done, except we're going to come back. I'm going to close the chart editor. Come back into the sheet. Let me make this bigger again. I want you to move and select cell B10. Select cell B10. You see it says trend line type equals, and now we've selected a blank cell next to it. We are going to write the type of trend line we just picked on our graph. We just picked the linear type of trend line. So type in linear and hit enter. In Google Sheets, you always have to hit enter in order for the sheet to save it. If you forget to hit enter after you type something, you close it out, you go back in, it's not going to be there. That's a mistake a lot of kids have when they submit things for me to grade. They forgot to hit enter after they typed it, and it shows up as blank when I look at it. You don't get credit. Let's do problem number 1 now together. Again, select cell A2, hold down your shift key, right arrow over and down. So your name box should say A2 colon B9. We're going to go to insert chart. Okay, we have some problems with this graph. Let's go to the customize option. The first thing we're going to change is our chart title under chart and axis titles. What do I have to change about the title? Get rid of the units. So delete them from the title. Now the title looks good. My vertical axis label looks good. The horizontal axis label looks good. But next thing you look for is here. I see 1 0. Do you have another 0 here? I don't either. Let me show you how to get it. I'm going to collapse this submenu, and I want you to find the menu that says horizontal axis. Do you see it? Expand it, please. Now you're going to scroll down with me. Scroll down until you see the option for min and max. You see that? Min and max. Min is the minimum value you want on that x-axis. And what should be on the left side of that x-axis? What number? A 0. So for minimum, go ahead, type in 0. Notice what that just did. Now I've got the 0, but something else also showed up. The vertical axis just showed up. We need that on our graph. You need that on your graph. So that's how you get it, by setting the minimum value on the horizontal axis. Okay, the only other thing we have to do is add the trend line to this. So where is that? Do you remember what submenu that's under? Series. Go ahead, go to series. And which type of trend line are we going to select? Is that linear? Now, Google Sheets is always going to give you linear first. What is it? Power series. Go ahead, down that option to power series. That fits it beautifully. Some of you may have a vertical line here, blue vertical line. That's the asymptote. That's the asymptote. It's showing you what it's trying to approach as an asymptote. Close your chart editor, scoot your graph over, drag and drop it, and then come down to your trend line type and type in the type. We said that was power series. Okay, there are two more. Can you try to do both of those yourself? And then we'll check them. I'm going to freeze my screen. And then we'll check all of them together in a moment. But see if you can make the graphs for problem 2 and 3 together, or on your own first. It's pretty easy, right? Anyone need more time? Okay, you want to start checking these with me? And then the rest of the time will be for you to work on those 2 graphs for homework. Nothing else with the Google Sheet. Okay, let's look at problem 2. Your title should be distance versus time. And you should have selected the trend line type power series. Yes? That was all you had to do. There was nothing else to edit on that one. Go to problem 3. You should have changed the title to speed versus time. Trend line type was linear. That's all you had to do. How'd we do? Good? Easy, right? There's more that we're going to do with this tomorrow. Not now. Do not turn in this Google Sheet. Just leave it. We're creating a resource for you to look back at things. So the rest of your time now is for you to work on the assignment that's due tomorrow. Pages 18 and 19 in your Unit 1 packet. Get those 2 graph problems done.